Welcome to Dr. Oven's classes again. Today we'll be treating chemistry. And this topic we are treating today is one of the, let me use the word, difficult topics that is always common with chemistry students. Balancing of chemical equation. Alright, now before we enter the main topic properly, let's look at what is really chemical equation. Chemical equation is an equation that has the product and the reactant. The reactant is always at the left hand side, which is the reactant, while the product at the right hand side. A plus B is a reactant. C plus D is a product. Now, let's look at the simple rules. When balancing a chemical equation, let's check what are the simple rules that we normally use in balancing a chemical equation. The first thing, the element that is present at the right reactant side must also be present at the product side. Now, what do we mean? If hydrogen, oxygen, and nitrogen are present at the reactant side, they must also be present at the product side. We cannot have hydrogen, nitrogen, and maybe chlorine here, then we are not having sodium here. Where did the sodium come from? So, every element that is present here must also be reflected at the product side. That's the first rule. Now, the number of moles of each element at the reactant side must be the same at the product side. If hydrogen is 1 here, hydrogen must be 1 here. If oxygen is 10 here, oxygen must be 10 here. So that's what it means, that the number of moles of each of the elements at the reactant side must also be the same at the product side. Now, 3. In a chemical equation, sometimes we see some chemical equation, they write S at the downside of a compound or an element. S simply stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous. That's what those things mean. Then the last one, when balancing a chemical equation, never you write numbers at the bottom side or the side of an element. Numbers are written at the front of each element, or it can be an element or a compound. Numbers are written. If parameter you want to balance this one against this, don't introduce numbers to this side or here. Always introduce numbers at this side. Do you get it now? Now we're going to be treating some examples. Let's quickly look at some examples and see how far we'll go. Alright, quickly, we're looking at some examples here. The first example, solution. The first example, A, said sodium hydroxide reacting with hydrochloric acid to produce sodium chloride and what? Water. Okay, now let's check if this equation is balanced or not. What do we mean by balance? Balance, it means the element here are the same with the element there. That's the number of moles here are the same with the ones here. Now let's check. Sodium. Sodium here we have 1 sodium. It's just 1. The 1 sodium here is also 1. So sodium is balanced. Now let's check oxygen. Oxygen here we also have 1. Oxygen there we also have 1. Now let's check hydrogen. We have 1 hydrogen here, we have another one here. That's to say hydrogen is what? How many? 2 here. So how many do we have here? We have what? 2. Are you getting it now? So let's check chlorine. Chlorine, how many do we have here? 1. Chlorine, 1. So that is to say this equation is perfectly balanced. This is what we mean by balancing of equation. To show that the number of moles here are also the same as the number of moles at this side for each of the element present. Now, this equation is balanced.